All right, let's talk a little bit about evaluating logarithms. So um, we've got a lot of different examples here because I want to make sure you understand how to evaluate these guys. You can shove most of these into a calculator. Pretty much every calculator is going to have base 10 and base e logarithms. Okay, and more modern calculators, you can do different bases. But just like when we're starting off any new thing, I really want you to understand how it works first before you just start typing stuff into a calculator. Okay? So let's think back to our last lesson about okay, what is a logarithm? Okay? Well, a logarithm is the exponent of a certain base that gives this result. So basically this, if I were to rewrite it, okay, so log base 3 of 27 gives us something. So if I'm to rewrite this, this would be 3 to what power gives me 27. So basically what all these logarithms are asking is, hey, what exponent do I need? 3 to the what gives me 27. 10 to the what gives me 10,000. 7 to the what gives me 1. Okay, that's the question that we're asking. So basically, all I have to do is I have to convert this into 3 to the something. And once I do that, I know what my answer is. So in this case, this would be 3 to the what? This would be 3 to the third. So my answer is 3. 3 to the third power gives me 27. And that's how we do all of these. So log of 10,000. Well, this is common log, so we're assuming that's 10. So again, I'm asking the question, okay, 10 to the what power gives me this? Well, what is it? 1, 2, 3, 4. This is 10 to the fourth. So 10 to the fourth gives me 10,000. All right. Log base 7. So I need to convert this to 7 to a power. Well, that's kind of weird. 7 to what power gives me 1? It's 0. Y'all remember that? Okay, any base other than 0, if you take it to the 0 power, you get 1. So this is going to be the case with pretty much any logarithm. So log base 8 of 1 is 0. Log base 27 of 1 equals 0. Log 1/2 1 equals 0 because 1/2 to the 0 is 1. 27 to the 0 is 1. 8 to the 0 is 1. It's that 0, 1 that kept showing up when we were doing exponentials. This is just reversing that process. Okay? All right, let's try this one. So I'm trying to convert this 0 to 2 to the something. Okay, well, I think it's pretty clear that we can't have any positives here. Okay, certainly not integers. If I do like 1/2, that's going to square root. What if I do negative? What's 2 to the negative? Okay. Y'all, this isn't going to work. Okay, so real quick, the exponential function that we did before, okay, what is the domain of this function? Well, the domain is all real numbers. We can get anything, we can put anything into our exponential function. What's the range? We had an asymptote here, remember? And nothing went below this. So our range is all of the values 0 to infinity. Okay, not equal to 0. Well, the way that inverses work, okay, is remember you switch your input and your output. You switch your x and y. which means for logarithms, we're going to switch our domain and range. Excuse the horrible picture there. Let me use a brighter color. There we go. So when we switch the domain and range here, our domain becomes 0 to infinity, and the range becomes all real numbers. Wait, who cares? Well, here's why we care. Remember, domain is the numbers that you input into your function. So it's saying what numbers are we allowed to shove into a logarithm? Only numbers from 0, not inclusive, to infinity. So when I try to shove a 0 into a logarithm, it's meaningless. It doesn't work. So this is undefined. I can't do 2 to any power and get 0. That's impossible. All right, let's try another one. My base is 5, so I need to convert this to 5 to the something. Well, that's pretty easy. 5 to the what power is 5? It's just 1. And again, this pattern you're going to see a lot as well. So if you see log 4 of 4, that's 1. If you see log base 10 of 10, that's 1. You see natural log of e, remember that's the base, that's 1. If the base and the result are the same, the only way that's going to happen is when your exponent is 1. Make sense? Someone out there in cyberspace is saying, yes, that makes sense, Mr. McClung. All right. So let's look at this. My base is 11. So I'm asking, hey, 11 to the what power is 11 to the 5th? 11 to the what power is 11 to the 5th? Well, it's 5. I literally already had it in that form. So y'all, when you have log, I don't know, 9, and then it's 9 to the x, well, that would be x. Because you're asking what the exponent would be if the base was 9, and the exponent's x when the base is 9. These basically cancel each other out. Okay, you're doing the logarithm and you're exponentiating. Those two things cancel out. All right, well, let's dive into maybe some trickier ones. All right, 8 to the what power is negative 1? Maybe I can do positives. Positive, no, that's not going to work. What about 0? 8 to the 0, no, that's 1. What about negatives? No, those are just going to be like rational values here, okay? Can we put negatives into a logarithm? No, we said before, our domain for logarithms is 0, not inclusive, to infinity. So I can't shove negatives into a logarithm. This is also undefined. All right. What about this guy? There's actually a problem with this on your homework, so make sure you're paying attention here. So my base is e. So I'm trying to convert this to e to the something. Well, we're almost there. We just need to rewrite this. So I can rewrite this as natural log of e to the 5/3. So what's my exponent of e? It's 5/3. Okay. Anytime you see radicals going on there, it's going to be easier if you can convert that to an exponent, because we know what's going on with exponent stuff. We it's more complicated if you put it in this form right here with the radical. All right, log base 10 of this. Okay, well, can I convert this to something with base 10? I can. That's going to be 1, 2, 3, 4. Negative 4. 10 to the negative 4 power. That does that thing where it moves that decimal place back 4 times. All right, what about this guy? Log base 4. So I need to change this to base 4. Well, that's going to be a little tricky. I know 4 to the third is 64 if you've got your cheat sheet. But that's not going to get me 1 over 64. So how do I get the reciprocal? It's going to be negative. So this is negative 3. 1/2 to get 16. Well, how do I use the 1/2 base to get me 16? What about 2? 2 would have been easier, right? Well, how can I turn this 1/2 into a 2? With a negative exponent. So if I make my exponent negative, now we're dealing with this as if it's 2. So 2 to the what power gives me 16? That's going to be 4. So 1/2 to the negative 4 power gives me 16. Okay, so 9 to what power gives me 3? Okay, there's kind of 2 ways to go about this. I want something with a base of 9 to get me 3. Okay, I know this can't be like a positive integer. It can't be negative because we're not dealing with like a fraction, like a reciprocal here. So I've got to be dealing with some sort of fraction, some sort of rational number. This is a square root. So this is going to be 1/2. Here's another way you could deal with this if you were having trouble. Okay, if you want, we can rewrite this as an exponential. And we can solve it the way that we did the other day. So let's get both of these to the base of 3. What's my exponent here? It's 1. 2x equals 1. X equals 1/2. Okay. So either way, my exponent needs to be 1/2. Let's do one more tricky one over here. Log base 4 is 8. I'm not going to try to do this in my head. Let's use that method that we just used where I go ahead and convert that to an exponential. 4 to the x power equals 8. All right. Well, getting these both to base 4 is actually really hard, but it's not bad to get them to base 2. Then I can set these equal, and my exponent is 3/2. Again, modern calculators can do all of this, okay? But it's going to be really important that we understand how these logarithms work, what they're doing. So I really encourage you to do these without a calculator so that the rest of the material will make a lot more sense to you, because this stuff shouldn't be too bad. All right, good luck.